What's up, everybody? This is Danny Mathematics again. Today, I want to go over example 1 of how to solve and graph inequalities, okay? It is the same step or the same steps that I used when I was solving equations. The only difference is that an equation is saying that both sides are equal. An inequality sign is saying that both sides are not equal, meaning that one side may be greater or lesser than the opposite side, okay? But once again, it's still the same steps in solving them. After we solve this inequality, we're gonna also graph it on the number line, okay? So once again, I have this inequality. It says negative 30 plus 16x is less than or equal to 6x plus 13x. Once again, negative 30 plus 16x is less than or equal to 6x plus 13x, okay? So the first thing, ladies and gentlemen, we want to do is to divide the room, and we're gonna draw a line, or I call it a fence, through the inequality sign. Okay, and I want to do that because I want to divide the room, because remember, we want to put everybody that's single, or all the values that are single, on one side, and all the values that are in a operational relationship on the opposite side, okay? Now, the next thing that we want to do, guys, is to combine like terms on both sides, okay, if we can. On this side, I can combine 6x and I can combine 13x, okay, because both of them are x to the first power, meaning that it's a like term. So I can combine those. So 6x plus 13x is actually 19x. So now I have 19x, and over here, negative 30 and 16x are not like terms, so I cannot combine them. So all I can do is just bring them down. So now, ladies and gentlemen, we have negative 30 plus 16x is less than or equal to 19x. All right, so let me just make my x's and my variables be blue so we can clearly see, and my inequality sign red, okay? So now this is what we have, okay? So now, ladies and gentlemen, it's time to identify what values are in an operational relationship and what values are single. As you notice, negative 30 does not have a variable attached to it, okay? Which means that it's single. So I'm just gonna put an S underneath for single. 16 is attached to X because it's actually saying 16 times X. So the operation between them is multiplication. So they are in a relationship. So I'm just gonna put a heart. And then 19 is in a relationship with X because it's actually saying 19 times X. So they are in a relationship, okay? So now what we want to do, guys, is label each side. We want to pick one side as the relationship side and the opposite side as the single side. So what I'm going to do is I'm going to pick, and it doesn't really matter what side you do, but in this case, I'm going to pick the left side as the relationship side, just because I want the variables to be on the left side, okay? And then the right side, I'm going to label that as the single side. So all my single values, or the values that I labeled as single, need to go on that side, okay? All right, so let's go through it. 16x is in a relationship, so it's on its correct side. But negative 30 is not in a relationship, it's single. So I need to do the opposite of negative 30, which is positive 30 or plus 30. So I'm going to add 30 to both sides. That crosses out or cancels out, and then I'm going to add 30 on this side as well. Okay? All right. Now, let's look here. On the single side, 19x is not single, it's in a relationship. So I need to move 19x to the relationship side, and the way I can do that is the inverse of 19x, which is negative 19x or minus 19x. So I'm going to subtract 19x on both sides. All right. Now we continue on. After we add or subtract everything and cancel things out, 16x minus 19x is a negative 3x. So it's saying negative 3x is less than or equal to, once again, that cancels out, but I have a plus 30. So it's gonna be a positive 30. So now I have a negative 3x is less than or equal to 30, okay? Now, this is a main factor, guys. If we notice, the coefficient or the number that's attached to x is a negative number. So because it's a negative number, that means that it is mandatory that we flip the inequality sign. So either you could do this right now or you could do this at the end. I would rather do it now. So flip the inequality sign. All right, you only do that if the number that's attached to the variable or the number that's attached to x is a negative. Whether it's a negative fraction, a negative whole number, or a negative decimal, okay? Which a negative whole number is an integer. So you can either be an integer, a fraction, or a decimal. If it has a negative sign that's associated with it, then we must flip the inequality sign. We must flip the inequality sign. So instead of it saying x, negative 3x is less than or equal to, now it's going to say negative 3x is greater than or equal to 30. So remember, because there's a negative coefficient, which is the number that's attached to the variable, you must flip the sign. Only for those. Now, if it was a positive 3, then you don't flip the sign. But since it's a negative 3, you have to flip the sign. Okay? So now I have negative 3x is greater than or equal to 30. Okay? Now, the last thing that we need to do, guys, is break up negative 3 and x. Once again, ladies and gentlemen, the operation within their relationship is multiplication, right? Because it's actually saying negative 3 times x. So in order for them to break up, you have to do the opposite or the inverse of multiplication, which is division. Okay? So in order for us to break up negative 3 and x, I'm going to have to divide both sides by negative 3. Well, once again, we already flipped the sign, so the sign is facing the correct way. So negative 3x divided by negative 3 is just x. Okay? Greater than or equal to. And negative 30 divided by negative 3 is a negative 10. So this is our inequality. It's saying that x is less than or equal to negative 10. That's what it's saying. It's saying that x is, oh, I'm sorry. I'm glad that I saw that. It's not saying that x is less than or equal to, it's saying that x is greater than, I'm sorry, x is greater than or equal to negative 10. Once again, x is greater than or equal to negative 10, okay? Now, the last thing that we want to do, guys, is graph. We actually want to graph the inequality. So you don't have to draw a whole number line. Just draw a short line and just put the number that's being compared to x in the middle. Okay, and just go maybe a couple up and a couple backwards. So once again, x is being compared to negative 10. If I go forward, right, or I become greater, that's negative 9. If I become lesser, that's negative 11. Okay, so just a little short number line just like that. It don't have to be long, okay? So once again, I'm going to put a circle over negative 10 because that's the number that x is being compared to. Okay, so the top part of the inequality is saying that x is greater than. Okay, the top part of the inequality sign is saying that x is greater than. So if I was going towards all the values that are greater than negative 10, that's going to the right. Okay, because negative 9, negative 8, negative 7, and so on are all greater than 10. I mean, than negative 10, all greater than negative 10. Okay, but we're not done because it's not just saying that x is greater than or equal to, not just saying that x is greater than negative 10. It's also saying that x is greater than or equal to negative 10. So if it's equal to, it could be equal to negative 10. That means that negative 10 is one of the values that x could be. So instead of us having an open circle, I have to shade it in because x could possibly equal negative 10. Okay? So this number line or this graph represents all the values that x could possibly be. Okay? X could possibly be negative 10. That's why I shaded it in. If it only said x was just greater than negative 10, we'll keep it open, meaning that it couldn't be negative 10. It only could be any values that are greater than negative 10. But in this case, it's saying x can either be greater than or equal to negative 10. So I shaded it in and I drew an arrow going towards all the values that are greater than negative 10. All right. So once again, this is the graph. Of it's saying x is greater than or equal to negative 10. Okay? So once again, ladies and gentlemen, this is how we solve inequalities. It's the same steps as solving an equation. The only difference is we have an inequality sign versus an equal sign. And whenever we divide both sides by a negative number, which is the negative coefficient, then we must flip the inequality sign, okay? So that's one major step that we have to remember whenever we are solving inequalities. And of course, we can also graph inequalities as well, okay? The next video, I will be coming out with an example 2 of how to solve inequalities. Thank you.